In this video, we're going to look at two main ways that we can solve systems of equations. These two methods should be reviewed from Algebra 1. We're going to look at graphing and substitution as two methods that we can use to solve these. Graphing we'll do with our graphing calculator, which will be helpful, and then substitution is going to be by hand. So let's get started. A system of equations is two or more equations with multiple variables. So this is an example of a system of equations. We have two equations in two variables, x and y, two different equations. Our goal to solve a system is to find all points that they share. So all points that these two lines have in common. Okay? There's a couple different things that can happen. So lines often intersect at a single point. Okay? This would be your solution. Occasionally, lines do not intersect. There's a little geometry for you. Parallel. These have no solution because there's no places where they intersect. And the last thing that can happen is we can have the same line given twice, in which case they share all points, and there's infinite solutions. Most often you're looking at this case, one solution. So the solution to a system of equations is the points where they intersect. So to do this problem, they're already both in y equals. Your calculator requires stuff to be in y equals in order to graph it. So we're off to a good start. So to solve this problem, I'm going to go to my y equals in my calculator. We're going to call this the y1 and this the y2 and type them both in. So negative 3x minus 6, 2x plus 4, and graph. This is going to be very similar to what we did in our last unit, our last section, the 4D and 4J section. We are trying to find the points that this line and this line have in common. That's the point where they intersect. That is what we're looking for. Two ways to find it. First way, second graph, will bring us to a table, and we can look for any places where their y values are the same. Now, from the graph, you can tell this is the only point they're going to intersect at. Lines don't just magically curve back and then hit each other again. This is the point. So if we can find one solution, we've got it. Second, graph. And it actually shows up right away for me. You might have to scroll a little bit, but right here. When x is negative 2, both of my equations have the same value, which is 0. When x is negative 2, they have the same value. That means that this point 2, 0 is on my first line, and 2, 0 is also on my second line. So x equals negative 2, y equals 0 is a solution. Sorry, that's a y. Another way you can find this same point is second, calculate. Number 5, intersect. You get your little cursor close to that point, enter, enter, enter 3 times. And there it is. Negative 2, 0 is that solution. This is an okay way to write it. A better way would be to write it as an ordered pair. This is the solution to that system. So what does it mean to be a solution to a system? We said it's the point that they have in common, or the point that they share. Additionally, if I were to plug that point into both of my lines, it's going to work in both. So negative 2 is my x value and 0 is my y. Let's plug them in. So I'm going to check the first equation. Y is 0 equals negative 3. X is negative 2 minus 6. Well, that's 6 minus 6. So that one checks out. This point should also work in my second equation. So let's see. Y is 0. 2 times x, which is negative 2, plus 4. That's negative 4 plus 4, so this works also. 0 equals 0. So this point is in fact, we did it with our graphing calculator, double checked it with a little bit of algebra, this is the solution to that system of equations. Let's do another one. This one's a little bit trickier. Because it's not currently in our standard y equals mx plus b form like this one was. Y here is not by itself in either equation. So we have to think back and do a little bit of algebra in order to get y by itself. So I'm going to start with the top equation. 4x plus y equals 0. Our goal is to get y alone, so I'm going to subtract 4x on both sides. So y equals negative 4x. That 0, right, kind of goes away. There's one of them. I'll do the same thing with my second equation. 7x plus 5y equals 2. First thing we need to do to get y by itself is subtract 7x. So 5y equals negative 7x plus 2. And then we need to divide by 5. Y equals. Now, you can divide both pieces, but that's not easily divisible, and neither is that. So I'm actually going to leave it like this and show you how to type that fraction into your graphing calculator so that you don't have to worry about simplification mistakes that you might make. So these are my two equations. We're going to take our calculator and we're going to put them both into our y equals. So first one's negative 4x. The second one is a fraction. So to get this big fraction bar, alpha, the green button, y equals. I love this button. It's number 1. It makes a fancy fraction for you, or fancy fraction is what I call it. It lets you clearly see what's on the top and what's on the bottom of your fraction. Please use this because it keeps you from having to remember that the top needs to be grouped together. You can actually see what's going on the top of your equation and what's going on the bottom. So I think this is a great button that the calculator has. So that was alpha y equals. It makes this little fraction for you. Let's graph them. There's one. There's the other. It looks like they're intersecting about right in here. You can go second graph to your table. And I don't quite see anything where they're the same. I'm looking for where y is the same. So that must mean it's happening at a decimal value. So we need to use our second calculate intersect button to find their intersection point. So we can scroll, we just need to be close to that point, and enter 3 times. And it pops up our solution. So you can see that our intersection point here is in fact a decimal value. That's why it wasn't showing up in our table. So the solution here, those are icky. Let's round to 3 sig figs. Let's practice a little bit. 3 sig figs. So my x is negative 0. Okay, that 0 is not a sig fig. It's 1538. 153. So those are my first 3 sig figs. And now that 3 is going to be pushed up to a 4 because of the 8. So 154. My y value is 0.615. The next value is a 3, so that does not push the 5 up. It's not big enough to. So this will be 0.615. You can write your answer like that, or a better answer would be as an ordered pair, x comma y. Okay, that's the graphing method. You can always use the graphing method. If you like it, use it. The only place where it's maybe not the most beneficial is whenever you have very difficult equations to solve for y. So if these are hard to solve for y, if you struggle with that, then you might want another option for solving systems of equations. So that's where substitution comes in. So this up here, this was graphing. The next one we're going to do is using substitution. So here's our example. X equals y minus 1. Once again, if you are good at solving for y, if you like doing that, solve them for y and do it that way. That is just fine. A-okay. But we're going to practice another method for solving systems of equations, because sometimes this way is a little bit easier. So the substitution method, you did this in Algebra 1, involves taking an item and plugging it into the other equation. So right here, x is equal to this. So down in this other equation where I see an x, since x is the same thing as this, I can replace this x with y minus 1. Since these are equivalent, x and y minus 1 are equivalent, they're equal, we can replace the x down here with this value. Alright, so let's do that. So this will look like 4 parentheses y minus 1. The x became a y minus 1, minus 3y equals 0. Why do we do that, you might ask? Well, we do that so we can get down to a single variable. We are now in the single variable of y. All the x's are gone. This x was replaced with y minus 1. It's not there anymore. So now we can solve this linear equation like we're used to. You are absolutely welcome to solve it with technology if you would like, using our strategy from last class. Or just solve it using algebra. So we distribute the 4. Combine our like terms. 4y minus 3y is y. And then add the 4 over. So y is 4. Up above in our first and second example, we had an x and a y value. But all we've found here so far is our y value. We have to take that and plug it back in order to find the x value. So x is equal to y minus 1. Well, y is 4. So x is 4 minus 1. So we're going to take this, plug it in there. X equals 4 minus 1. So x is 3. So our answer here is 3, 4. That is where those lines would end up intersecting if we graphed them. Okay. If you want to solve them for y and do that method, you are absolutely welcome to. Your two equations would end up being, the top one would become y equals x plus 1, and the bottom one would be y equals, and it'll be a fraction, negative 4x over negative, so we'll make it, right, you can make those positive, or you can do it like that. So it could be 4x over 3 or negative 4x over 3. All right, let's do one more. I'm going to change papers. All right, last example. 2x equals y. 2y minus x equals 1. This top one's already solved for y. The bottom one wouldn't take too long to solve for y, so you're absolutely welcome to graph. I'm going to do this one using the substitution method. So the variable that's already alone is the y. Y is equal to 2x. That variable is alone. So down here where I see a y, I'm going to replace it with 2x. Since y is the same as 2x, in the second equation where the y is, I can put 2x instead. So, what's that going to look like? 2 times 2x minus x equals 1. 2 times 2x is 4x. 4x minus x is 3x. Divide by 3, and x is 1/3. So, how do we find y? Well, we take that value, plug it in for x, and it's going to tell us what y is. So 2 times 1/3 equals y. 2 times a third is 2/3. Now when I get kind of icky answers like this, I always doubt myself, and I wonder, did I do this correctly? So how could we check? Well, you can always plug the point you found back in and see if it works. Just like we did on the first example, okay? I'll tell you this is right. So if you want to plug it in and check, you're always welcome to do that. I encourage it. But for this, I'm just going to stop there. All right, this gets you going on section 4H. 4H also goes through elimination, but it's not as important for us in what we're trying to move towards, so we're just worrying mostly about graphing and substitution. If you remember elimination from Algebra 1, feel free to use it. You're absolutely welcome to solve these systems however you see fit.